Let us start. Yesterday, I have discussed biaxial stress condition, which means a prismatic bar is subjected to a loading into mutually perpendicular direction one along x-axis, say x-axis, one along y-axis. And what is the stress we have calculated? What is the stress condition exists over a plane AC, which is inclined at an angle theta with the normal plane. Normal plane means a plane BC, which is normal to the longitudinal axis of the constant prismatic bar. What we have done, first of all, we have to know what is the component of the stress sigma x and what is the component of stress acting first along the normal force sigma theta and along the shear force or tangential force tau theta. So we have to find out the component of sigma x and multiplied by this length, the length of the side TC is equal to dy, which is normal, which component is acting along the normal stress sigma theta over basic axis, and what is the component of this force which is acting along the shear stress sigma theta of this force sigma y dy. Similarly, we calculated what is the component of this force sigma y dx, which is acting along the force sigma theta and which is acting along the force tau theta. And we have, in order to maintain the balance, we have equated them. So we have equated them to each other, and for the multiplication of that as per the proper orientation will be equated to 0 to maintain the equilibrium of the situation. Now, thus, to follow this procedure, what we have got the value of the sigma theta, and we have got the value of tau theta, which is given here. Next, we are supposed to calculate. What is the resultant force of this angle sigma theta and tau theta. What is the resultant force? That is sigma r, which is the resultant of the forces sigma theta and tau theta, means this sigma theta and this tau theta. What is the resultant of this force which is acting along this direction? That is sigma r. And what is its orientation? So we are supposed to calculate now all this. It is. We know resultant stress is equal to square root of sigma theta square plus square root of plus tau theta square. So if we put this value of sigma theta here, that is half sigma x plus sigma y plus half sigma x minus sigma y cos theta whole square plus minus half sigma x plus sigma y sin 2 theta, which is given here, and sin 2 theta whole square, which is given here as well as here. These two lines which we are supposed to extract. So we are using this portion as well as this portion as sigma theta and tau theta, and its whole square we have calculated here like this. Now, what will happen if we put these respective values of sigma theta and tau theta and make the whole square? What will happen? One half will become 1/4 sigma x plus sigma y whole square plus 1/4 sigma x minus sigma y whole square cos square 2 theta plus 2 into this half into sigma x plus sigma theta multiplied by half into sigma x minus sigma y into cos 2 theta, like this. As these two in the numerator is cancelled by the 2 into 2 in the denominator. So this becomes half sigma x plus sigma y into sigma x minus sigma y cos 2 theta. And the square of this portion minus half sigma x plus sigma y times sin 2 theta is equal to 1/4 sigma x minus sigma y whole square plus sin square 2 theta. So we can, if we simplify, what will happen? This thing half 1/4 sigma x plus sigma y whole square remains as it is, and here this portion will become sigma x whole square minus sigma y whole square into cos 2 theta. Thus it comes here, and this remains, and this thing remains. If we take the meaning of this thing and this one, this will become 1/4 sigma x square sigma y square multiplied by cos square 2 theta plus sin square 2 theta. This is equal to 1. So this thing remains 1/4 sigma x minus sigma y whole square only. So what we have 1/4 sigma x plus sigma y whole square plus 1/4 sigma x minus sigma y whole square plus half this sigma x square plus sigma y square into cos 2 theta. Next, if we simplify further, what will happen? This 1/4 sigma x plus sigma y, sigma square plus sigma y plus 2 sigma x sigma y. Here sigma x plus sigma y minus 2 sigma x sigma y plus half sigma x square minus half sigma y square multiplied by cos 2 theta whole over the square root. So here this thing is cancelling each other, and this 2, this is 2 into sigma square and this is 2 into sigma y square, and these two altogether will get half sigma square plus half sigma y square, and this remains as it is, half sigma x square minus sigma y square into cos 2 theta. Thus, if we can divide, thus we can fit this sigma x square and together. So this sigma square, half sigma square is into 1 minus plus cos 2 theta, and if we put sigma y square together, it will become plus half sigma y square 1 minus cos 2 theta. And if we simplify further by putting the value of cos 2 theta is equal to cos 2 theta is equal to 2 cos square theta minus 1, and here cos 2 theta 1 minus equal to 1 minus 2 sin square theta. We put them together in the respective places and simplify again. Respective places and simplify again. It will become this minus will be cancelled by this minus. This will be cancelled by this minus, and this minus will be cancelled by this minus, and this, that is the effect of this minus equal, this will become plus and this will become minus. So this becomes 2 into cos square theta multiplied by half into sigma x square plus half into sigma y square into multiplied by 2 into sin square theta. So further reduction will lead us, these two will cancel each other, and so sigma x square into cos square theta plus sigma y square into sin square theta is the our square root itself. This is the value of sigma r, the resultant stress of these two induced stress sigma theta and tau theta in terms of sigma x, the stress induced on x direction, sigma y, stress induced on y direction, and theta, the angle of the plane with the normal of the normal plane. The angle of inclination of the resultant with tau theta. Just 1 second. Now, the angle of inclination is sigma tan phi tau theta by sigma theta. Put the value of the respective value of items like tau theta and sigma theta, which is minus sigma x sigma y sin theta cos theta divided by sigma x cos square theta plus sigma y sin square theta, or sigma y minus sigma x, and if we divide this thing by cos square is divided by sin square by sin theta cos theta, and sin square theta divided by sin theta cos theta. So this one sin will get placed here and one cos will be placed here. This becomes cos by sin, which is cot, and this is the sin by cos, which is equal to tan. So becomes sigma x cos theta plus sigma y tan theta. For great obliquity or inclination of the resultant, is the greatest obliquity or inclination can be with the normal spaces given by if will be achieved when we require equity critical to 0. So thus it becomes sigma x cos x square plus sigma y sec square, which is here. This is equal to 0. Sigma x tan phi. Oh, if the make the derivation with respect to theta, what will have? This cot theta will derivation of cot theta is equal to cos x, and derivative tan theta is equal to sec square sec theta. When it becomes square like this, and 2 will eliminate each other. So this equation becomes tan phi sigma x minus sigma x divided by sigma x into cot theta minus sigma y tan theta. If we make d tan theta here divided by d theta, so we are equating first of all we have to d by d theta sigma y minus sigma x minus d by d theta, not d, but here. D by d theta multiplied by cot theta plus sigma x cot theta plus sigma y tan theta cot square theta cot square theta. This is cos, one cos is cancelled here. Now this cos is cos, one cos is cancelled, cos by sine, one sine is cancelling here, sine by cos. Now there's only one cot theta sine theta. So that we have to reduce again. Yes. So this will be equal to minus sigma x cos x square theta plus sigma y sec square theta. Which is here, we are putting it equal to 0. So sigma x cos x square to sigma y cos theta. So sigma x by sigma theta is equal to sec square theta divided by cos x square theta is equal to sigma x by sigma y. Sigma x by sigma y. So sec square theta is equal to 1 by cos square theta divided by 1 by sin square theta is equal to sigma x divided by sigma y, or equal to sin square theta by cos square theta equal to tan square theta equal to sigma x minus sigma y. So tan theta is equal to square root of sigma x by sigma y. Now tan phi max, which becomes, if we put the value of theta here, then you could tan phi max, yes, they are putting this value of cos theta and tan theta here. Just 1 second. What is tan phi max? Which is equal to you have to put sigma x. Sorry, I got it shading. Oh, when I we have got this equation, tan phi is equal to sigma x, sigma y minus sigma x, sigma y minus sigma x divided by tan phi sigma y minus sigma x, sigma y minus sigma x divided by sigma x cot theta minus plus sigma y tan theta. Then the maximum value of theta is equal to tan theta given by square root of sigma x divided by sigma y, which you have just got. So what will be that? Cot theta square root of sigma y by sigma x and tan theta remains there. If we put it here, what will happen? Then tan phi, the maximum value, tan phi max, it is sigma x minus sigma y minus sigma x multiplied by sigma x into square root of sigma y and sigma x. That's we put it here, then sigma y, and put this thing here, square root of sigma x by sigma y. So what will happen here? This portion will become, remains as it is, sigma y minus sigma x, and this portion becomes sigma x multiplied by sigma x to the power minus half multiplied by sigma y to the power half plus sigma y multiplied by sigma y to the power minus half multiplied by sigma x to the power half. We are just converting the square root as half. So sigma x multiplied by sigma x to the power half is equal to sigma y minus sigma x is sigma x to the power 1 minus half minus the power 1 minus half multiplied by sigma y to the power half plus sigma y to the power 1 minus half multiplied by sigma x to the power half. This becomes sigma x to the power half, or sigma becomes sigma y to the power half. So this is becomes square root of sigma x into sigma y plus square root of sigma y into sigma x. And this equation does become sigma y minus sigma x will get 2 into square root of sigma x, sigma y. So the maximum value of theta is here. If you get the value of theta will be that sigma x and sigma y, square root of sigma x and sigma y, and maximum value of phi. That is the theta is the angle between this. What is the angle theta? What is theta? That theta angle between the plane AC to AB, AC to BC, AC to the plane ABC, which is normal plane. And tan phi, what is the angle phi? It is the angle between the angle of inclination of resultant with sigma theta. Thus, this angle maximum, this is the maximum angle here, type tan theta max. The maximum angle of inclination will be sigma theta by sigma y, and maximum angle of inclination of the resultant will be sigma y minus sigma x divided by 2 into sigma x and sigma y. So both these things can be easily calculated. We know the value of sigma x and we know the value of sigma y itself. Now, what the above result shows us, the above result shows us the following. The normal stress on the inclined plane varies between the values of sigma x and sigma y. And still angle theta is increasing from 0 to 90 degrees, or it is more than 90 degrees or equal to 90 degrees, it will become sigma is equal to sigma theta. So the normal stress varies between the value of sigma x and sigma y as angle theta is increased from 0 to 90 degrees. For equal value of 2 sigma x with sigma x and sigma y, sigma theta is also equal to sigma x or sigma y itself. The shear stress is 0 on plane with angle theta and 90 degrees. When theta is equal to 0 degree, means when this normal plane is not exactly normal, but is equal horizontal to the line of action. And when this plane is of 90 degree, it's the same, that is horizontal and vertical planes. So the shear stress is 0 on planes with angle 0 degree and one angle 90 degree. When it is horizontal plane, when it is a vertical plane, there is no shear stress. It is maximum value is numerically equal to half of the difference between the given normal stress with occurs at plus minus 45 degrees to the given plane. So tau max here half is equal to half multiplied by sigma x minus sigma y. And the normal stress across the same plane becomes sigma 45 degree, put the value of theta is equal to 45, means cos 90 degree, which is equal to 0. So becomes half sigma x plus sigma y. So maximum tau max is equal to half plus minus half sigma x and sigma y. and there sigma x, sigma x is not, theta is not 0, but equal to the half of the addition of sigma x plus sigma y. The shear stress in a body subjected to equally perpendicular stresses is 0. So if uh, if a body is sigma is equal to sigma y, then what happens? Shear stress sigma theta comes here, and this sigma x minus sigma y will be 0. So this tau theta will be equal to 0 itself. Now, if any of the given stresses are compressive, the stress can be replaced by a negative sign in the above derived equation. So sigma with, if sigma is become compressive, it become minus sigma x, and sigma y become compressive, it will become minus sigma y. Just a minute. If sigma y is compressive, the maximum value of shear stress across the plane is at 45-degree plane will be half sigma x minus into minus sigma y, half sigma x plus sigma y. And if sigma x is numerically equal to sigma y, then tau max is equal to sigma x is equal to sigma y. Next comes another situation where it is being mentioned that pure shear stress condition. Let an element of the body acted upon by shear stresses on the two mutual perpendicular faces, as in the bottom figure. Here, what we have found here, the body which is being truncated, body was like this. We have a inclined plane which is acting at an angle theta with a normal plane equal to theta. Equal to theta, and it is subjected to shear stress at the angle at this line, and tau x shear stress at this line. So there is no tensile stress, but only shear stresses are visible. So what we are supposed to do here, what I have told you, the element of the body as given, as shown you here, the dx, dy, and ds is the length of the side AB, BC, and BC. So considering the unit thickness of the body and resolving the force in the direction of sigma theta. So what we'll do here, we have two forces, tau here and tau here, they are equal. So, but this is the length equal to dy, and this is the length equal to dx. So this force, let us find out the component of this force dy into tau along sigma theta dx, and component of the force tau dx along sigma theta dx. So we have to here, we have to take the or this element, and here we have to take and this element, and the in between angle will consider. Thus, this considered the unit thickness and resolving the forces, theta and tau theta. Tau theta ds, sigma theta ds will tau into dx cos theta. That means tau theta ds, tau theta dx cos theta. Dx is 1. Tau theta dx is the cos theta because here the independent angle is tau. So tau theta dx cos theta, and here tau theta dx sin theta. Here the independent angle is equal to tau theta. Here this is theta. Here this is theta. First we have to find out what is what. What is theta? What is not theta? So this is the theta. So this normal force, this tau dy multiplied by sin theta is, which is acting in this direction, is opposite to here, and tau theta, tau dx multiplied by cos theta is acting in opposite direction. So both are negative. This becomes tau dx, the positive project, tau dx sin theta, tau dx sin theta, tau into dx sin theta. No, this becomes theta itself. See, tau dx sin theta. Yes, tau dy cos theta minus the plus tau dx sin theta is equal to 0. So if we first divide both sides by ds, this will take this shape, tau dy cos theta divided by ds minus tau dx sin theta divided by ds, which is equal to tau dy cos theta, dy replaced by dy by cos theta, and dy here ds is replaced by dy by dx by sin theta. So here sin theta is replaced with theta, and dx is being replaced here, dy is replaced here, replaced by each other. So tau cos square theta minus tau sin square theta, tau 1 minus 1 plus cos 2 theta divided by 2 minus 1 minus cos 2 theta divided by 2. So tau cos 2 theta. This is the forces in direction of tau theta. Similarly, the forces in the direction of sigma theta, tau sigma theta ds, tau dx cos theta, that is tau dx cos theta is here. This is negative side. Tau dx cos theta, this is theta. So sigma theta is opposite tau dx cos theta minus this, and tau dx sin theta, which is here at this direction, which is plus tau dx sin theta is equal to 0. So both are negative here because both are opposite direction. This is acting in this direction, as well as this thing is also acting in this direction. This component is also acting in this particular direction instead. So both sigma is dx is equal to tau dy into sin theta minus tau dx into cos theta, which is equal to 0 for sigma theta. Next, we are following the same procedure afterwards. We divide both sides by ds. Then ds is replaced by, in initial first case, dx by sin theta, and next case dy by cos theta. And this dy is replacing each other. This dx is replacing each other. This becomes tau sin theta cos theta, or tau sin theta cos theta, because 2 into sin theta cos theta, and 2 into sin theta cos theta, so sin 2 theta, tau sin 2 theta. And so sigma theta here in case of pure shear is equal to tau sin theta, and in case of sigma tau in case of pure shear, it is tau cos theta, cos 2 theta, sin 2 theta, cos 2 theta. The resultant, again in the same procedure, that it shows up that the plane for theta is greater than 90 degrees, and down the plane theta is greater than 45 degrees. Resulted on the plane at sigma r, square root of sigma theta plus sigma r, and put the respective value tau sin square sin 2 theta whole square plus cos 2 theta whole square, and this becomes sin square theta and cos square theta. This becomes equal to 1. Becomes square root of sin square 2 theta plus cos square 2 theta. this will become 1. So tau into or sigma r 0 to tau. The inclination between them, sine 2 theta by cos 2 theta, tan phi, sine 2 theta by cos 2 theta, there because tan 2 theta of theta phi is equal to 2 theta. So the angle of inclination with the normal plane when the part is subjected to shear stress in no other pressure or compressive stresses, the angle of inclination will be given by and maximum angle of actual shear stress of the tan phi 0 to phi is equal to 2 phi. The above this equation states that the normal stress is positive when theta between 0 to 90 degrees and negative compressive between 0 to 90 degrees. Normal stress is positive when theta is between 0 to 90 degrees and negative when theta is 90 degrees for 180 degrees. And maximum values being 45 degrees is equal to tau and 135 degrees is equal to tau. The shear stress is positive clockwise for tau is equal to less than 45 degrees and negative for tau greater than 45 degrees. And minus for 130 degrees, again positive between 135 and less than 180. The shear stress is 0 at 45 and 135 where normal stress is maximum. So what we are saying, what are the given here? The normal stress is positive when theta is between theta to 90 degrees. So what will happen here? What is theta to 90 degrees? This position here, the theta is 0 to 90 degrees. So here normal, what is the value of normal stress? Sine 2 theta and 0 to 90 degrees, then normal stress sigma theta to tau theta, where sigma theta sine cos 2 theta, I think, sine 2 theta. Tau multiplied by tau cos 2 theta. Normal stress sigma theta tau sine 2 theta tau sine theta pure stress condition tau cos 2 theta. So this is positive when theta is between 0 to 90 degrees, means when if we put